All right, good evening. This is Team One. We are discussing tonight the Dow Jones Industrial Stock Centramizer, which is a application through Django and other applications to show you a kind of a result by which we're going to basically show stocks of the Dow Jones Industrial Average and a particular recommendation that is based on some algorithms which will be discussed in this particular presentation. Next slide, please. This project that we have been working on over the course of this semester, it will focus on a stock market domain, which is basically motivated by our interest and experience in stock trading and financial analysis. It's built on a web application that displays the stock data and then the sentiment analysis for those 30 Dow Jones Industrial Stock Average companies. The feature is based on generating a short-term price change projection, so approximately a week, and it's based on correlating sentiment and these headlines and historical stock price movements. My colleague in a minute will explain to you specifically where that sentiment algorithm is coming from, and I will spend a little bit more time on the base, which in this case would be our idea of what we call a moving average, convergence, divergence apparatus that will allow us to basically have a strong or anywhere between a strong or a sort of a weak buy and sell recommendation on a 5-point scale. Several studies have shown that the natural language processes of news and social media data can predict short-term stocks, and the project aims to implement these changes. Next slide, please. The methodology, which we'll get to in a little bit more, this is like the framework. There's a pipeline, machine learning, there's a server-side architecture, and there is a web application framework. And from a financial standpoint, we're using what we call a moving average convergence divergence tool, which is basically taking the difference between a slow-moving and a fast-moving exponential moving average, and then the line that will oscillate through that particular time over a period of approximately 26 days and another period of 12. The intersecting line will then make the determination whether the stock is actually a buy or a sell recommendation. And on top of that, we also are doing a sentiment analysis that then automatically will parlay this into a 5-point scale ranging from a strong sell to a strong buy. I will hand it now over to my colleague, Brendan, who will give you a little bit more information about that. Next slide, please.
So before we get into the machine learning pipeline, I wanted to take a minute to explain the natural language processing model we chose to move forward with, which is the FinBERT model, how we used it and why that's important. So at its core, FinBERT is a variant of the BERT model, which is itself a variant of the transformer model, which is a type of artificial neural network that utilizes a mechanism known as self-attention to learn long-range dependencies in text. Now, unlike its predecessors, BERT was unique in that it could understand the context of each word in a sentence because it was not unidirectional in nature. It took the entire sentence of a given text and understood the meaning of each word based on the surrounding words around it. Now, as innovative as this approach was, BERT still struggles with analyzing financial text due to its inherent complexity. So, for example, going long or short on a stock or describing a bear or a bull market can mean very different things in a financial context versus everyday usage. It's for these reasons we chose to move forward with the FinBERT model. So FinBERT is a fine-tuned version of the original BERT model that was exposed to large amounts of financial text during its training process. This fine-tuning enables FinBERT to better understand the financial jargon and, more importantly, sentiment in the context of financial markets. This version of FinBERT that we used was hosted on the Hugging Face library, which was important because it allowed us to pull in that model into our Jupyter Notebook by simply calling the Hugging Face API. This approach greatly reduced the complexity of our notebook and greatly reduced the amount of time and computation it took to generate these sentiments. Next slide, please. This is a very high-level overview of our machine learning pipeline. We used a platform known as DeepNote, which is a collaborative Jupyter Notebook environment in order to accomplish these 4 steps you see on the screen. Step 1 was to use a service called FinHub, which provides an API that we called into the notebook to aggregate news headlines for all of the 30 companies that comprise the Dow Jones. We performed our natural language processing using that FinBERT model on those headlines. Step 2, we calculated the moving average convergence divergence score that Peter alluded to earlier, and combined those signals with the sentiment scores we calculated in step 1. Step 3 was cleaning the data and providing the user with a stratified recommendation of either strong buy, hold, sell, or strong sell. And the 4th step was simply to provide that information in a way that could be used for further processing. In this case, we saved it as a CSV and uploaded it to a shared Google Drive. I will now pass it to Mike to explain the server-side architecture.
So to display all this to our users, we needed a web app. Our app infrastructure consists of a Django Python framework with a SQLite 3 database for our application. So to streamline development collaboration between our team members, we built a CI/CD pipeline using GitHub and Docker to automate the build, deployment, and version control of our code across different machines managed by different users, and to deploy and build the code on our final web hosting server on render.com. So we use the FinHub API, just like we used it in the machine learning section, to display our financial data and news. We use Django's material dashboard, which is a quick start kit to give ourselves a starting point for UI and design, and to add some ready-made reusable Bootstrap components that we can reuse. And we used Allauth to add GitHub and Google account integration to simplify the sign-in process. So with our CI/CD pipeline, code push to the master branch of our Git repo automatically deploys to our application hosting server on render.com, and it's built using Docker tools and Django management scripts. So DeepNote fetches new data from the FinHub API daily and generates a new sentiment score and recommendations, and those are manually migrated to our web server to update our Sentimizer data. Too many user requests in a short period of time will cause an HTTP 429 response from the FinHub API, which is an API limit reached error. To get around this issue and optimize our API requests, prevent application failure when we would hit the API limit, we cache each data request in our user database. If a 429 response is returned, the application instead serves the most recently cached data. And with that, I'm going to go ahead and take a look at our actual live app. So first, we're going to go ahead and sign in. You can sign in with a username or password, create a new account, or you can use GitHub or Google. We're going to go ahead and go with Google. I'm already signed in on this browser, so it'll automatically sign in with my Gmail account. And then we have a stock list with some basic financial data. So we can take a look at any one of these stocks. I'll go ahead and go with Raytheon. So on the left side of the screen, we've got the Raytheon ticker along with our recommendation. We've got candlestick data with the most recent financial data. We've got open, high, low, and close, some basic financial data about the stock. And at the bottom, we've got our sentiment score and our Sentimizer's recommendation. On the right side of the screen, we've got the latest news about the stock, which is also what our machine learning pipeline is analyzing to calculate the sentiment score and make recommendations. With that, I'll take it back to the slides and I'll hand it over to Steve.
So the objectives we set out to achieve with our project included the retrieval of financial data from FinHub, a financial API provider, which we use to retrieve both historical stock prices and news headlines. We wanted to implement a FinBERT natural language processing model to analyze sentiment on financial news headlines. We wanted to develop a moving average convergence divergence trading algorithm to generate signals from price history. we wanted to combine the sentiment and technical signals into a recommendation system to leverage a SQL-like database to store stock price history and financial news for later retrieval, and to display stock data, news, and recommendations in a web application. Next slide, please. A summary of our results include that the project was able to acquire pricing data on 30 stocks over 30 days and 5,000 news headlines over 1 week, leveraging the FinHub API. Our Finbert NLP model was able to score the 5,000 headlines for sentiment in under an hour. The moving average trading algorithm we developed generated signals from the price history data in just minutes. Our application combined the sentiment predictions and moving average signals into a set of 5-point buy-sell recommendations for each stock projected for the upcoming week. We built an interactive web application with Django that displays the recommendations along with historical charts and headlines. These results demonstrate the successful implementation of an end-to-end machine learning pipeline for integrating financial data APIs, NLP sentiment modeling, algorithmic trading strategies, and web visualization. And with that, I'll hand it back to Peter.
Next slide, please. Okay. So far, our experience has been extremely positive, also from a particular algorithmic standpoint and the combined financial data with the natural language processing. We were able to interact with web APIs at a scale to acquire the financial data. We were able to optimize the natural language processor pipelines to score sentiment data on thousands of text examples. We were identifying correlations between the sentiment signals and price movement. We have developed and evaluated algorithmic trading strategies, created an end-to-end data science system integrated into a web app, managing a complex project with multiple components and dividing tasks, and building data visualization and user interfaces for our surfacing insights. And then next slide, please. For our future enhancements, these are the ones that were probably the easiest to obtain, because I'm assuming that there will be a significant amount more if you are extending it to a much larger, in this case, universe of stocks. But one would be, of course, automated deployment of sentiment analysis and stock recommendations from DeepNote to a render accessible endpoint to make it somewhat easier for the user. API upgrades to increase real-time accuracy. So far, the API that we're using, specifically FinHub, comes with a little bit of a cost, and the free data, like Mike already alluded to earlier, is even though it's free, it has some restrictions as to the number of calls you can make to it. Currently, it's only refreshing with live data until, of course, the API limit is hit. And the other one would be that, of course, we're trying to save stock data to favorite lists, and of course, adding the ability to invest directly within the application, which would be a significant, increase in its functionality and its applicability. So next slide, please. In conclusion, the project has successfully combined the data acquisition, machine learning, and web app development and deliver a sentiment-aware stock analysis tool. It was able to address certain core challenges like accesses to web APIs at scale, optimizing sentiment scoring models, and quantifying signals of data. The integration of the new sentiment and technical indicators for generating projected returns kind of demonstrated how machine learning can be used to augment traditional financial analysis. And then from a process perspective, our team gained a valuable experience in the agile project management. First of all, pivoting to a new API, adapting the machine learning pipeline, and of course, the project reinforced some core software engineering principles like encapsulating functionality, separating concerns, and continuous integration. And this basically concludes our presentation. I hope you enjoyed it. Next slide, please. And then this is Team 1. Our members are Mike Setzer, Steve Jimenez, me, Peter de Jong, and Brendan Dow. And I hope you have a great night. And this concludes our presentation. Thank you so much.